Chapter 7 Database. Intro. A database is one of the main issues in the field of computer science. In its early days, the database was used for a narrow field. However, thanks to the advance of network technologies, the extent of its usage has grown. In these days, a web database is widely used through the World Wide Web. We'll study the concepts and types of the database in this chapter. The concept of the database. A database is often abbreviated DB. A database is a collection of information organized in such a way that a computer program can quickly select desired pieces of data. You can think of a database as an electronic filing system. Traditional databases are organized by fields, records, and files. A field is a single piece of information, a record is one complete set of fields, and a file is a collection of records. For example, a telephone book is analogous to a file. It contains a list of records, each of which consists of 3 fields: name, address, and telephone number. The hypertext database and DBMS. An alternative concept in database design is known as hypertext. In a hypertext database, any object, whether it be a piece of text, a picture, or a film, can be linked to any other object. Hypertext databases are particularly useful for organizing large amounts of disparate information, but they are not designed for numerical analysis. To access information from a database, you need a database management system, DBMS. This is a collection of programs that enables you to enter, organize, and select data in a database. The classification of database. A database is a collection of information that is organized so that it can easily be accessed, managed, and updated. In one view, databases can be classified according to types of content: bibliographic, text, numeric, and images. In computing, databases are sometimes classified according to their organizational approach. The most prevalent approach is the relational database, a tabular database in which data is defined so that it can be reorganized and accessed in a number of different ways. A distributed database is one that can be dispersed or replicated among different points in a network. An object-oriented programming database is one that is congruent with the data defined in object classes and subclasses. Computer databases typically contain aggregations of data records or files, such as sales transactions, product catalogs, and inventories. Typically, a database manager provides users the capabilities of controlling read/write access, specifying report generation, and analyzing usage. Databases and database managers are prevalent in large mainframe systems. But they are also presented in smaller distributed workstation and mid-range systems such as the AS/400 and on personal computers. SQL, Structured Query Language, is a standard language for making interactive queries from and updating a database such as IBM's DB2, Microsoft's Access, and database products. Relational database. A relational database is a collection of data items organized as a set of formally described tables. And the data can be accessed or reassembled in many different ways without having to reorganize the database tables. The relational database was invented by E.F. Codd at IBM in 1970. The standard user and application program interface to a relational database is the Structured Query Language, SQL. SQL statements are used both for interactive queries for information from a relational database and for gathering data for reports. In addition to being relatively easy to create and access, a relational database has the important advantage of being easy to extend. After the original database creation, a new data category can be added without requiring that all existing applications be modified. Big data. Big data is a buzzword, or catchphrase, used to describe a massive volume of both structured and unstructured data that is so large it is difficult to process using traditional database and software techniques. In most enterprise scenarios, the volume of data is too big, or it moves too fast, or it exceeds current processing capacity. Despite these problems, big data has the potential to help companies improve operations and make faster, more intelligent decisions. An example of big data might be petabytes, 1024 terabytes, or exabytes, 1024 petabytes, of data consisting of billions to trillions of records of millions of people, all from different sources, e.g. web, sales, customer contact center, social media, mobile data, and so on. The data is typically loosely structured data that is often incomplete and inaccessible. Important factors of big data. Volume. Many factors contribute to the increase in data volume. Transaction-based data stored through the years. Unstructured data streaming in from social media. Increasing amounts of sensor and machine-to-machine data being collected. In the past, excessive data volume was a storage issue. But with decreasing storage costs, other issues emerge, including how to determine relevance within large data volumes and how to use analytics to create value from relevant data. Velocity. Data is streaming in at unprecedented speed and must be dealt with in a timely manner. RFID tags, sensors, and smart metering are driving the need to deal with torrents of data in near real time. Reacting quickly enough to deal with data velocity is a challenge for most organizations. Variety. Data today comes in all types of formats. Structured, numeric data in traditional databases. Information created from line-of-business applications. Unstructured text documents, email, video, audio, stock ticker data, and financial transactions. Managing, merging, and governing different varieties of data are something many organizations still grapple with. How about letting yourself and others have access to a company database, which is usable from any location that has a browser with an internet connection? The web database concept makes sense if you and your people want to do work in various locations in or outside the office and still be plugged in. For example, you could have employees enter timesheets or have sales reps log their contacts. Or perhaps you'd like customers to be able to check the status of their orders online without having to call the company. Typically, what happens is that a database such as Access or MySQL, basically just consisting of tables, would be put on the web. Then dynamic web pages, actually ASP pages which include VB-script, HTML, and/or JavaScript, would be created acting like the old desktop database's queries, forms, and reports to access the database, all hosted on a web server. Dynamic web pages are similar in many ways to regular HTML pages. But they are live because the user can read from and write to information in the database. Summary 1. The power of the www comes not simply from static HTML pages, which can be very attractive, and the important first step into the www, but especially from the ability to support those pages with powerful software, especially when interfacing to databases. The combination of attractive screen displays, exceptionally easy-to-use controls and navigational aids, and powerful underlying software, has opened up the potential for people everywhere to tap into the vast global information resources of the Internet. Summary 2. There's a number of ways that can be provided for the user to navigate and locate information in an information system, or data resource. At the simplest end of the spectrum, if your data can be structured as a small table and you just want to retrieve records according to one or two field values, then a small custom program will suffice. On the other hand, if you want to be able to search for complex interrelations in the data, then you may need a relational database.